Alright guys, welcome back to another Math Simplified video. Today we'll be talking about multi-step equations and variables on both sides. So solving multi-step equations. So here you can already see that when we solve multi-step equations, we basically have variables on both sides of the equation. For example, in this case, you can see here that there's a 2x over here, and then there's a 4x over here. So we're still trying to solve for x, but this time it's on both sides of the equation. So it's both sides. So solving multi-step equations. Multi-step equations require more than one step to isolate the variable. It is important to follow the correct order of operations as you solve these equations. So what it essentially is saying here is that it requires more than one step. We got to isolate the variable and it will require multiple steps. So it's not as simple as one step equations now. It requires more steps, more strategies to solve these equations. So here we have an example. This is a pretty easy example. 4x plus 3 equals 19. So, here we just basically subtract, the 3 from the positive 3 to move it to the other side. And then we also subtract it, on the right side. And now we have 4x equals to 16 because 19 minus 3 is 16. Then afterwards, we now gotta divide by 4 to cancel out the 4 up here. And then we also divide by 4 on the other side, on the right side, to balance out the equations. Just so you know, I already made a video about one-step equations, so you can go check it out first. So our solution here would be x equals to 4. You can tell here that we subtracted 3 from each side of the equation. And then afterwards, we divided each side by 4. So this was after we subtracted by 3, 4x equals 16. And then once we divided by 4, we basically isolated the x, and our answer is x equals 4. All right, so here we have a better example of what multi-step equations are. So we have 6x minus 9 equals 5x plus 3. You basically move the numbers that don't have variables. And in this case, the numbers that don't have variables are -9 and 3 because they don't have an x. All right, so we can either move this number here or this one to whichever side. I'm gonna just choose the negative one since I want to keep my numbers positive, okay? So I just move the 9 to the other side, so I'm gonna do the opposite of -9, which is +9. So then these two cancel out. And then I move the +9 also to the right. And since we're combining like terms, you cannot add 5x and 9 since 9 doesn't have a variable or 5 doesn't have a variable. So they're not like terms. So what we do is we leave the 5x the same, and then we combine the like terms here in this case, which is 3 and 9. So what's 3 plus 9? Well, that's 12. So we already combined our like terms that do not have variables. So now our second step is to combine the like terms that do have variables. So what we will do in this case is move the 5x to the other side of our equation. So how do we do that? Well, we subtract by 5x, doing the opposite of positive 5x. Then these will cancel out. We move the -5x to the other side. And then 6x minus 5x, we can subtract that since they're like terms. So what's 6x minus 5x? Well, that would just be x by itself, or 1x, if you guys didn't know. So our solution would be x equals to 12. Okay, so now we have another example here, which is 3x plus 5 equals to 7 plus 5x. So the first thing we do, in this case, we have 3x plus 5 equals 7 plus 5x. The first thing we could do is move the two numbers that do not have variables. So I'm gonna just move the one that has the least power. If you look at the absolute value between 5 and 7, which one is a greater number? 7, obviously. So we're gonna leave the greater value in the same position as it is, and we're gonna move the one with the least value. So 5, we're basically moving it to the other side. So here we subtract 5, here we subtract 5, and then our new equation will now be 3x equals to 2 plus 5x. Okay, so now since we combined our like terms and now we basically moved the numbers that did not have a variable and stuff, now we can move the numbers that do have a variable. So in this case, we would have to move the 5x, even though it has a greater value, to the other side, since we cannot move the 3x to the other side since it would just be 0 and we just can't do that, okay? So here we subtract by 5x. And then here we subtract by 5x. These two would cancel out. And then 3 minus 5x, well, we can subtract that since they're like terms. And then our new equation will now be negative 2x equals 2. So now what we do is divide by negative 2 because we also got to bring the negative sign with us since the x has to be positive once we isolate it. So these two cancel out. We also divide by negative 2 on the right side. And then our answer will now be x equals to negative 1. And this is our solution. All right, so here we have common mistakes to avoid. So the first common mistake to avoid is forgetting to distribute before combining like terms. That's a key, like that's something fundamental. Like you gotta distribute first before combining like terms. If not, your whole equation is wrong, okay? We gotta know PEMDAS because the first thing we do in distributive properties is distribute what's inside of the parentheses. Okay, now second most common mistake to avoid is moving the wrong variable to one side. So let's just say uh we're trying to solve, I don't know, for 8x. Why move 8x over here and subtract it, by 10 since they're not like terms? That's a big mistake. Then not applying inverse operations to both sides. So you always gotta apply inverse operations. And then our final mistake is losing track of negative signs. So if you forget a negative sign, it completely changes your answer. So please make sure that you include the negative signs and don't lose track of it. So check your solution by substitution, like that's something important as well, just to make sure that you got your answer right and it's, the most perfect solution. All right, so here we have a couple of practice problems. I'm not gonna do all of them, but I'll do the first three then. So here we have 5x plus minus 4 equals to 2x plus 8. So the first thing we do is either move this one or this one because they don't have a variable. So we always move like the first step is always to move the numbers that do not have a variable because we're trying to isolate already the 5x and stuff. So then afterwards we can isolate the x. So I'm gonna just move the 4, the negative 4. So I'm gonna just do the inverse of it, which is positive 4. These two cancel out. And then I add by 4 here. And since they're like terms, we can add them in there. So 5x, so our new equation will now be 5x equals to 2x plus 12. Sorry guys for the space, but yeah. So 5x equals 2x plus 12. Then afterwards, we move now the ones that have a variable. So now we subtract 2x to cancel it out. And then we subtract 2x as well here. And then 5 minus 2, that would just be 3. We also bring the variable with it. And now our new equation will now be 3x equals to 12. So then afterwards, we divide by 3 on both sides to isolate the x, since these two would cancel out. And then our answer is x equals to 4. So that's our solution to the first one. Okay, our second one is 3x, 3 times parentheses x minus 2 equals to 5x plus 4. So the first thing we do is distribute the 3 because this is distributive property. Remember, one of the most common mistakes is combining like terms before distributing. That's wrong. Always solve what's in the parentheses first. So we distribute the 3x and the 3 on both of these terms. So 3 times x, well, that would be 3x. And then 3 times negative 2, well, that would just be negative 6. So we distributed there. So now we can combine like terms afterwards. So this is our new equation. So I'm gonna just do it here. 3x minus 6 equals to 5x plus 4. So now we move the negative 6 since it has less value, and these two would cancel out. 3x equals to 5x plus 10. And afterwards, we gotta move to negative 5x because we don't want to leave a 0 on the other side of the equation. So 3 minus 5, that would be negative 2x. And then these two would cancel out, so now it would be 10. So we divide by negative 2 now to cancel out these two and isolate the x, and then 10 divided by negative 2. So our answer will now be x equals to negative 5. So that's our solution. All right, our third problem. 8 minus 2 times parentheses 3y minus 1 close parentheses equals 4y. So we just leave the 8 as it is for right now, and now we distribute the 2 since it has a parentheses right next to it, and that's distributive property. So 2 times 3, well, that would be 6y. This is a different variable now. So remember, don't confuse y and x. They're basically different variables, and that's what we're supposed to solve on these equations. So if you see y in this case, we solve for y. If you see x, then we solve for x, okay? So 2 times 3, that would just be 6, and the negative sign. And then negative 2 times negative 1, well, that would be 2. And then equals 4y. So now we distribute it. So now we can combine like terms. If you see here, we have on the left side an 8 and a 2, and those are both like terms. So that means we can combine like terms on our left side of our equation. So it's 8 plus 2. Well, 8 plus 2 equals 10, and then we keep the negative 6y equals 4y. So now that means that we would have to move, the negative 6y to the other side. So now positive 6y, these two cancel out. Positive 6y, that would equal 10y. So now 10 equals to 10y, and now we divide by 10 to isolate the y. So now our solution, 10 divided by 10 just equals 1. So our solution equals to 1. So that's our solution. All right, guys, I'll leave these three problems for you guys to do. Hopefully you guys solve them and leave it, in the comment sections, or just email me afterwards what you guys got for these solutions, like for these equations. Hopefully you guys understood this lesson, and I'll just leave the practice problems. Just like pause the video or something. All right, so thank you guys for watching this video. Hopefully you guys understood solving multi-step equations, and I'll see you in the next video.